Okay, this example isn't very concrete. This will be more clear, I think, when we do it in the examples. Okay, I'll be quick on this one. It's not very concrete. I'm not given any of the values. And this will be clearer, I think, when we do it in particular questions later on. But the idea is when we've got a point that lies on a particular line, okay, the idea is that that point A, whatever A is, its position vector is given by this mess here. So A, B, C plus lambda lots of D, E, F. And very often it will be convenient to combine that, as I've done here, into a single vector. Okay, and then we want to find out something about, or we've got some condition on the vector AB. So AB, well, if I've got OA, then I'm just going to do OB minus OA, if I can get that right. Okay, so OB is going to be, well, the position vector of B, which you know, because that will just be a normal vector. And this OA will be this vector here, which will have lambdas in it. A, B, C, D, E, F will be numbers, so that won't be too bad. So we'll get AB will be some kind of vectors which will have lambda terms in them and number terms in them. Okay, and that's the vector AB, which I need to be, in the first case, perpendicular to a line. So the first example here is supposed to be called A. Oh yes, A. You're given another coordinate B, so AB is perpendicular to the line. So in the first case, A, AB, this vector I've got here with lambdas in, is going to be dotted with the direction vector of the line, which again I haven't got. Well, yes I have, it's DEF, I suppose, vector, and I've got 0. So it'll be this horrible vector with lambda in, dotted with DEF, whatever that is, equals 0, and I'll solve to find what lambda is. And once I know what lambda is, I can plug it back into the equation of the line, and that gives me, remember, plug it into this and find OA, so I know where A is. Okay, and then for part B, same process again. A is on the line, so OA is this, and AB, if I've got another point B, is workable out, OB minus OA. But now the modulus of this, so I'm going to do the modulus of this horrible vector with lambdas in and numbers in. Okay, so there'll be numbers and lambdas in this. Okay, the modulus of that is just going to be the square rooty thing, so they're going to be lambdas being squared in lots of different brackets. Okay, as well as numbers. So you square all of that out, and this has got to equal, the modulus of AB is equal to a known vector. That should say a known distance, shouldn't it? Otherwise it makes no sense. So this is going to equal the distance. So you square both sides of this, and this gives you a quadratic, and lo and behold, you'll be able to solve that to find lambda. Okay, now if that didn't seem to make much sense, well, you know, it's not very concrete, as I say. So hopefully when we do examples that require us to do the point A lying on a particular line, this may actually be a bit clearer. Hope that helps.